Okay, welcome back to our lecture on CS1010E. Today, we are going to talk about something very difficult. Just now, we have a briefing for exemplified usage for midterm and finals. If you haven't come late or you haven't watched that, please remember to see how do we do exam. Without that, you cannot do any midterm or final exam, okay? But before we start, I would like to announce something quite difficult. Of course, we discover some people using AI or ChatGPT for assignment. Okay? And it's quite obvious. Okay, there are a few obvious things. We know that you are using ChatGPT and so on. For example, like overusage. What in earth you need to write a very simple function, but you need to use exceptions and very complicated algorithms, okay, and so on. Of course, you may be like that, but I would say 99% of time is using ChatGPT. What will we do? We will continue checking, so we'll give you a warning. We'll continue checking. If it's too serious, we'll actually raise up to the department. We don't care, okay? We're not going to do anything. You and your department deal with it. And usually the resulting will be fail or your grade or even expulsion of the university. We're not kidding, okay? So take care of it yourself. If you're using AI, I don't want to create conflict between us, so I will just give you to the department. And second thing is, let's say you luck out, no one discover you, you gain the marks from the assignment, then what? You fail all your PE and midterms. Okay, so you may barely survive, and I don't know why do you want to do that. Okay, this is a course. And lastly, you pay for this course. You come to learn something. The ultimate goal is not just getting a grade. The ultimate goal is getting some knowledge. Okay, so you want to really learn Python, and I really encourage you. I don't mind you will use some ChatGPT to help yourself, but please write the code yourself. I told you the exam, the parable in the beginning is like after 4 years graduation, you are so happy, you pay for all the air ticket, go to whatever country, US, Europe, or whatever, Alaska, or Asia you want. You pay for everything, but at the end, you ask your brother to go and let you to see the video. You just watch the copy of your travel. You don't want to do that, right? This is what you experience, what you learn, and at the end of the day, what we teach you in this lecture is going to be in your skill set for the rest of your life. And again, lastly is, we do have a lot of engineering students, after they graduate, they come back to learn Python again. We have a graduate course, MCOM, General Track, which if you come back at that time to learn Python again, it costs you 3,000 Singapore dollars per course. So you redo that again for 3,000 Singapore dollars. Do you want to do that, or do you want to learn it now? Okay, so that is really encourage you to not start cheating. And one last thing, sorry, I'll be trying, hey, if this is a 1,000 level, you already cannot manage it. I don't know how do you manage your 2,000 level, 3,000 level, 4,000 level course in your coming study, okay? It's not that hard for Python writing some for loop, and it's going to be the same logic methodology in your coming 3-4 years. So I really want to say this last thing. If you cannot manage this course, how are you going to manage 2,000, 3,000 level courses? Okay. So let's start. But on the other note, today will be one of the most difficult topic today. Okay. So just some prevention. If you are lost today, it's okay. Tell yourself it's okay, okay? The world is not ending yet, okay? Today will be very difficult. And what we're doing today is something called functional programming, in which is what CS major learned when they are coming to computer science major. CS people take the course called CS1101S, which they don't learn Python. they learn JavaScript with only function. That means try to imagine you do your previous assignment that you are not allowed to use variable. You are not allowed to use for loop. All thing you have to do is through recursion. That is what they do. Okay? But we'll have a glimpse today. So let's see how. And today we also need a bit of your calculus. But don't worry, very simple calculus. I will believe you guys come to engineering, you will know simple calculus, right? Like differentiate of sine is equal to cosine. I just need you to know all this, okay? I have a concept of calculus, that's it. Because calculus, I don't know, actually, to be honest, I would say in engineering, especially electrical and electronic engineering, calculus is quite important. Okay, so this is my favorite calculus parable. It's like a function is the coffee bean. You differentiate one become coffee powder. And then after that, you differentiate 2 times, become your favorite coffee. Okay, so let's start. Ready? Okay. What is this? Very simple. X equal to 1, right? Do you remember what happened? I said that if you talk about x equal to 1, yeah, x is a variable. X is a container that contains a contents called 1, right? So what does it mean by x plus 2? You will actually go to look for what is containing in x. At this point, x is containing 1. So you are actually, doesn't matter equal x or y, right? You get the content of 1, and 1 add 2 becomes 3. Very trivial. Okay, nothing new here. What is this then? 1 plus 2 is equal to 3, right? What is the difference between x plus 2 and 1 plus 2? Finally, we come up with 3, right? However, I would like you to know that the left example, x plus 2, has another layer. That means I want to call this literal with 1. I call it x. I give it a name. It's okay? I give it a container. But container, is it really matters? Does the container matters? In this calculation, it doesn't matter. So I want you to have in mind now, actually the 2 things. One is the container x, one is the content 1. Sometimes the name x doesn't matter. Does it matter I call x is equal to 1 or y equal to 1 or z equal to 1 or my counter is equal to 1? Doesn't really matter. What is matter is what is it containing, which is 1. The real usage, or we actually will promote to another level, the functionality of the content. Okay, let's start. This is the introduction. Again, fish or fish. Okay, what can ring in your bell? What is the different meaning of fish and fish? You know, especially in English, we have this so-called proverbs, right? You give a man a fish and he will eat it for a day. But if you teach a man how to fish, then he can be benefit for the whole life. Okay, some proverbs. What is the difference between these 2 fishes? One is a noun, right? One is a verb. Okay, so if you want to talk about Chinese, they have something similar. So the Chinese, but Chinese is different. Chinese, the 2 fish have 2 different shape. Okay, so for those people who don't, or those different radicals. Okay, so this is same meaning. So I would like you to think about, oh, the fish can be the object, the real fish that jumping around, or you can eat, or you can cook, or the fish is actually an action how to get a fish. So this first fish here is an object, a noun, a concrete stuff. The second one is a verb, a method or a function. So what is this? is a function that I will return a string of fish. Okay, by now, I think you should be able to understand this. It's a very simple as in the almost have no meaning function. What is happening when I say this? When that function is being defined, now I say x is equal to function. What does this mean? What will x contain? Fish, right? The string of fish. So I would like you to, it's all recap now, nothing new yet, so don't worry. So it's like the X is Mr. X, okay? He's a person. He asked for a fish. And you have a fisherman. The fisherman is actually producing a fish for the Mr. X, right? So Mr. X is like a variable. He's going to receive a fish. The fish is from where? The fish is actually from a function called func, okay? Okay, so nothing very new yet, but I want you to think about that. This is what we had so far. However, what if I want to say a variable x is equal to a function that return fish instead of the fish? What does that mean? We are going to learn something called high order function. Before we continue, just something we haven't touched yet. When you define function, you usually define function like this, right? But actually, you can do this. This is what we didn't talk about. What did I do here? What did I do here? I can actually define a function inside another function. Okay, what is the difference? The difference is the square function is a local function. I think you understand what is a local variable, right? Local variable is a variable that can only be accessed within a function. And then this is a local function. That means the square function is not available for everyone. You only can use the square function within the function called distance, okay? This is just some feeling before we go on. So the function is outside the function distance, you cannot access the square. So it's a local function. So it's a global function usually we are doing, and this is a local function. Now let's start our lecture. What we want to do today is we want to treat the function like a variable or values. What does that mean? First of all, if you notice, a function is callable. What does it mean? I can call it okay? For example, if I define a function x, I can call it. But is this a function? X equal to 1. Is it a function? No. Only a function is callable. You can call a function. You cannot call an integer. You can not call a string. You cannot call a list. They are not callable. The function have this callability that you can call. When you call the function, it runs, right? For example, if I define a function called f, I can call it. When I say f, putting these two parentheses, then it's calling the function. The function is like the cooker. You press the button and then it runs and will perform something inside the function. But normal data type like integer, floats cannot be called. Okay, so I think this is something we already know. And also, if you remember lecture 1 or 2, all the variable can be perform this assignment. I can assign a value to the variable, right? For example, x equal to 1. That means I put the value 1 into the variable x. Then I put the variable x into y. That means y now contain 1 and so on. This is the variable assignment. We taught it in lecture 2. Now, open your eyes big. How about this? Can I say this? I define a function f. I say x equal to f. What the heck it means? Here, you have to notice one very important thing. When I say x equal to f, I am not doing x equal to f with the parentheses. Without the parentheses, only with the letter f, the function f is not called. So what is doing here? Here is the variable x is the function f. Is it okay? X is not what f have returned or resulted in. X is the function f. It's like you create a function called f, but now you give him an alias. I also call x is the same function. Can I call x? I try to call x now, and I can. It's okay. I can use another variable to say that, oh, this is the other function. But when you do the assignment here, you don't use the parentheses. Without the parentheses, f is just the name of the function, and you can pass it around. And so x is actually the function f. When you call f, you call f. When you call x, you also call f. So what is the difference between this? Let's say now I define another function called f2. This function f2 will return a value 999. Now we have two parallel universes. First, why is that so? X is equal to f2 with the parentheses. Is f2 being called and executed here? Yes, right? f2 is being called and execute. So you go into the function, it's like the rice cooker. You press it, it starts cooking and give you the result of the rice. And this function, this function f2, will give you the result of 999. So 999 is after this f2, the machine blah, 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 finish and give you the product, which is the return. And 999 will be stored in X. So if you put a parenthesis there, the function is being executed and you give you the result, and that's why X is 999. This is nothing new, okay? This is what you have been doing for the past 5 weeks. How about this? I do another y. Y is equal to f2 without the parentheses. Another question, same question. Is f2 being executed or being ran here? No. Good job. No. f2 is not executed. What I did is, now I give another name. This is called y. Y is also f2. So when you checked what is the y, when you even print it or ask what is the type of y is not 999. Y is the function. And the function in Python will give you something like, oh, it's a function to f2 at, this is actually the memory address, okay? You don't have to care about it, but this rubbish code is actually the memory address where is this function is being located in the memory. So I would like you to notice now you can actually store a function in a variable that is not the result. Okay, so one is with the parentheses, one is without the parentheses. That makes a difference. So the left one, the function is executed, the right one is not. Okay, and not only the function you create can be stored, even your default Python variable you can store. For example, after I import cosine function from math, I can say I don't like cosine. I want the function to be called f1. The f1 is the cosine function. You just give another name for that. Okay? And if I say f10, it's equivalent to say cosine 0. So f1 is just another name for cosine. And of course, it's the built-in function. For example, this one is another function. And you can even put the function in the array or list. My list is my favorite function, like there's some favorite function I like. The first one is cosine. I learned it. I learned my cosine function when it's on my 10 years old birthday. I like it. And I collect the other function is sine because it's like Singapore. And I like the function f. The function f is the function that is the first function I define when I learn Python, whatever. Okay, so I put it, and the array is storing all this function. And you can just get any of them by the array, like my collection 4. What's that? So you can, cosine is index 0, sine is index 1, tangent is index 2, f is index 3. That's why collection 4 is the length. When you get it out, it's just like the length function. Then what is the length function of this list 1 to 3? Then it's 3 lah. Yeah. So you just access the function by the list. Okay. And we can do function composition. You can do function of function, right? That is, I think this is not a difficult concept, but I can do in Python because I can actually input a function into another function as a local parameter. You can see that I define a function called hello, and this another function is called to twice. That means whatever you input in X, I will treat it as a function and call it 2 times. So if I do twice f, I will say hello, hello. Okay, so I will do the function 2 times. And it's equivalent to say f, because I pass f into it. I can do any mix and match. For example, one of the functions is called add 1 to x, which means I will return the result of increment 1. The other one is square x, we are very familiar. And then I will do this function called do 3 times. And what it does is, I will input one of the parameter is a function. And the other parameters is a variable, is numbers. So what this do 3 times function do is, I will apply the function 3 times to my n. So what is I add 1 to do 3 times to 2? Because if I do 1 times, 2 will be incremented by 1, right? And I do another time, will be incremented by 1 again. And 2 incremented 3 times is what? Is 5. Okay, so I will apply this function 3 times to my 2, and each time will increase by 1. And I can do 3 times in square. So 2 square is 4. 4 square is 16, and 16 square is 256. So be 256, I lost track, okay? So I can apply this 3 times to 2. So we can play around with the function like a local variable. If you can understand, I can store a function in a local variable, you can pass it around, throw it around, and so on. Okay, that is not the gist, because what is the point of all this? Just now we've learned that instead of Mr. X getting a fish, actually Mr. X is containing the method of fishing. So Mr. X did not get the fish object. He's actually remembering the function that will produce a fish. So, but that's not all, because we are going to the next level. First, you give man a fish. And just now we learned that you can teach a man how to fish. What is the next level? You teach a man how to teach people to fish. Okay? So this is what we really want to do. We haven't talked about that yet. But don't be like too, wow, what is that so profound? No, we have been doing it in university. We have CTTL, we have all this educational institution will teach people how to teach, right? MOE is teaching people how to teach and so on. So it's not nothing new. So go back to our thing is, when your variable is just receiving an object from a function, it's like giving it a fish. And what we learned just now in the past 10 minutes is, I can use a variable to contain a method. The verb variable is actually recording a function. However, the ultimate goal is, I want the variable containing a function that can produce function. I call it a function factory. Your function can produce many functions for you to use. What is a normal function? Come back from heavens, come back to earth yet. What is the usual function we do? Like a square function. What does that mean? A square function is, I can produce different value for you to use. Square 2, I produce a 4 for you. Do you like it? Square 3, I produce a 9 for you to use it. Do you like it? So the square is producing different value for you to use, right? Square 10 is 100. So the square function is taking in an input, but I will give you produce different integers. Now we just do the same thing, but I will get some input. I will produce many different functions for you, and that's what we call high order functions. It's the evil lambda. Okay, lambda is the Greek letter L. Okay, Greek letter L is called lambda, but in the mathematics major, they have this thing called lambda calculus, which even mathematicians think that, wow, it's so big enemies. Okay, you know, usually you go for games, there's this hidden big boss, right? So the lambda is usually used for that. Before we go for something very serious, participation time. What is this? The one with massage, hot water, what do you call that? Yes? Jacuzzi? Okay. Remember that first. What do you call this? Ping pong. You sure? What do you call this? Huh? Sorry, what's that? Huh? Bubble wrap. What do you call this? Huh? What's that called? Roller skate, right? I heard roller skate. Finally, what do you call this? Huh? What do you call this? Huh? Tape. Okay, but usually people will refer to Scotch tape. Okay, and congratulate. All of you got it wrong. All you just called, even including ping pong, is brand name. We humans sometimes use the brand name to label the object. For example, do you call every cell phone Apple iPhone? Yours Apple iPhone, then other fans like Android or Huawei will beat you up, right? Mine is Android phone, mine is Huawei phone, right? Mine is Samsung phone. But Apple is a brand name, right? And cars, you have Honda. You don't call every car Honda. You call it a car. But do you notice we humans sometimes make the mistake, we use the name for a brand to represent a whole bunch of similar products, like Maggie Mee. You know, Maggie Mee is a brand name. Maggie is like in Hong Kong, we call every instant noodle door noodle, 公仔麵. But it's actually a brand name. Usually the real thing is Pao Man, right? Is instant noodle. But we call it all things 公仔麵 because we name it. So Jacuzzi is the company that produce hot tub, and actually the best product they do is toilet. Even ping pong or even bubble wrap and roller skate, they are brand names, not the real product's name. For example, What is this Scotch tape? Scotch tape, the real definition is pressure sensitive sticky tape. And if you go to 3M, they have this tape, they won't call it, this is the 3M Scotch tape. Because Scotch is a brand. There's a brand called Scotch. And that's why they call it Scotch tape usually, right? So Ping Pong is a brand. Bubble wrap also is a brand. Okay, the bubble wrap is not a real object. I don't know what it's called in real nature. But I want you to notice that there's a name for the functions. You have to use a name to name it, right? For example, if I call you, I'll call you your name, Peter, whatever. I won't call you, did you do your homework, human? I won't do that, right? I won't say that, do you do your work, Singaporeans? You won't do that because you need to use a name to identify something. But on the other hand, we want to produce something. It may be an obstacle we name things names. Like Apple produce a lot of iPhones. They won't give every iPhone a name. This is Apple iPhone Pro Max Hemi. This is iPhone Pro Max Dolly. You won't give all of them a name because it's a mass production of different functions. So if we want to produce something, you may not even to give it a name. Remember x is equal to 5. We talked about it in the first beginning of the lecture, right? We are actually giving a name to the 5 is parallel to, we want to give a functionality of squaring a number. I want to put a name as square. Do you realize I can call this function anything I want? I can call this function f. I can call this function, I want to sabotage people, I will call this function square root. But actually it's squaring things, right? The name has a function, the name has a variable. X is the name of the variable that containing integer 5. Square is the name of the functionality that will square some function. 5 is the real object it's going to operate. And it's like the function, the functionality that you take in a number and square it is the real substance of this function. And for integer, I can use the 5 without a name. I can directly say 1 plus 5. And that's why we are going to do it for the functions. From now on, we can actually produce a function without a name. For example, if I want to use an integer without a name, it's very easy. I just say print 5 is plus 1. How do I create a function without a name? I use lambda. The yellow part of this is I create a function. This function is a lambda function. The syntax is it would take in the x. Do you see there's a colon before the colon there's x? That means it's the input parameter. And directly I tell you what does it return. It returns x times x. That is the function. Okay. I can store up the function. For example, this is our normal way of defining a function by giving it a name. I can do this. Lambda x, that x plus 1 is the functionality I want. I can put it into a function, and this function applied to 9 will produce 10. Actually, I'm not trying to express myself fully here. What does that mean is, if I define a function like this, lambda x plus 1, it itself is already a function. I don't even need to write the notes. Put it to a function called func. I can directly do this. Because it's a function, right? Whole function. You can 112. This itself has a functionality. For example, I can say lambda y times y. And then this itself is a functionality. So this one is already a function, like a normal square, but just without a name. Okay? So the syntax is quite simple. The syntax is lambda. For example, I say lambda, I can put more than one parameters like a, b, and then I will return a plus b. This is the function that you add two numbers. So what I can do is lambda 1 and 21. Okay, so this is the lambda function. I apply to these two parameters, like a normal function calling, and return me the addition. I can do this. I can do this like hello. Well, okay. I can also do that. Okay, so as far as the functionality is there, I can apply to anything. So, for example, the add one function and this function are totally equivalent, except that the new lambda function I define, I don't need a name. And I don't need to explicitly write a return because I will assume I will return whatever at the end. So apparently, this is nothing new. Why do I need to do that? Why do I need to avoid the name? But it's useful when you want to write a function that return a function. Which means, how do I make a function that is a function factory? For example, what is this function? It's a function that adds n. What does it do? It returns a lambda. It doesn't return a value. It produces you a function. But I will need to get one input first, which is n. Now, f1 is equal to our function at n with 10. What does that mean? That means this f1 is this one. Except I already know what is n because 10 is being input. It's okay? f1 is equal to lambda x plus 10. Now I can use this function 1 to some number. f12 is 11. f11 is 11. f12 is 12. And this cool function, and I can produce another function called f2. And this another function that I produce is 1899 instead of 1810. So this add n function, I can produce any function you want that add any number. I can even compose it f1 and f2 to play around with what I want. And with all this, let's start our major usage. Ready? Why do we want to do that? Because we can actually not only creating or output or return an object by a function. I can actually have a function called function factory, return any function you want. For example, it's a simple usage. I will make power function. What does it mean? My make power function will take is n. And I will return a lambda that the lambda function is taking x, that x to the power n. For example, I can make power function 2. Whatever it is, the function with power 2, that is a square function, right? I can make a cubic function. Whatever power function, I power 3. I even can make the square root. Why? Because if any number power 0.5 is a square root, so I can even make a square root number out of this make power function. So this make power function is a function factory. I output a lot of different functions. However, let's try to do this called agar-agar differentiation. Okay, what is it agar-agar? And I hope everybody knows what is agar-agar. Agar-agar is anyhow lah, similar lah, okay? So if today you want to get 100 marks, 19 right, okay lah, okay, this is agar-agar. And we bring back a bit of calculus. And then still remember this? How do you define a differentiation? You differentiate this function is all this Newton limit, whatever. But anyway, what I want to do is, this is when you need to derive it. I don't want you to understand this first. What is differentiation? First of all, philosophical. Let's get to them philosopher. What is differentiation? Our differentiation is you can use this formula, but you can actually use a rough idea. Sorry, I jumped. What is differentiation? You differentiate sine become cosine, right? You differentiate this x cubed plus 3x whatever become another function. But do you notice that differentiation is a function factory? I take in a function and I produce another function. Differentiation is a function factory. I take in sine, I give you cosine. I take in cosine, I give you negative sine. Differentiation is a function factory. And what I want you to do today is, let's implement differentiation with 3 lines of code. What does that mean? This is the real differential formula, right? I don't know why this Newton is so clever. He do this. But what we want to do today is we want to do agar-agar. This one requires your delta x is very, very close to 0. But if you directly compute this, make a delta x very small, you get a pretty good result already. What does that mean? We want to create this function factory that whatever function you give me, I will give you a function that is the differentiation version of it. And there's the code. There's the code for differentiating anything. What does that mean? Differentiation say this, right? Differentiate this function is equal to this function. If we have a very small dx, so I set a very small dx. And if you give me a function, I give you this, fx plus dx minus fx divided by dx. Don't believe? This code will create differentiation. For example, you know the normal cosine, 0, 1, 2, 3, I produce this. Let me do this. I use this function to put in sine. Differentiating sine should be cosine, right? I put the sine function into my differentiation function. And I give a function factory effect that produce a function. What is this function? I use this new function is exactly, not exactly lah, similar to cosine. It's accurate up to that many digits. If your dx is even smaller, you can get an even more accurate result. So I can differentiate sine myself. And again, if you don't believe it, try again. For example, this is the function, right? X to power 3 plus 3x minus 1. I try to differentiate it and apply a value of 9, then give you 246 point something. But if I directly use an analytical formula, which means because differentiating x to power 3 is 3x squared, differentiating 3x is equal to 3. Differentiating negative 1 is 0. So if you put 9 there is 249, 246. My 3 lines of code here, go back to this one. These 3 lines of code over here. I can throw in any functions that I can produce a function for you that is the derivative of it. then you ask yourself, why do I need to study 4 or 5 years in my secondary school? What is it for? Okay. So this one, basically, you can differentiate most of the function now. But of course, if you go back to Newton's, whatever, you need to know that the function has to be differentiable, rational, whatsoever, that kind of thing. But most of the function, you can use these 3 lines of code as a function factory to produce function. And some more. So this derivative function, I will flow in a function into my function, which means I flow in a sine function, and I will produce and give you out a cosine function. And that's not the end. I try to save the world. Anyone remember what's Newton method? Or anyone knows? Of course, you know who is Newton, right? Newton Isaac. There was this Time magazine, you know, US have this Time magazine. He do a survey, the whole world. Who are the most influential persons within the recent 3,000 years? After that, it's opinion, don't sue me, okay? The 3 persons are, I forgot what's the order. The first one is Jesus Christ. The second one is Muhammad, from Muslim. And the third one is Sir Newton Isaac. Okay, don't sue me. This what Times Magazine is, sue Times Magazine, whatever. It's talking about most influential, not most correct, okay? Why? It talk about how many people they influence. Okay, you know the first 2 are religious figure, influence a lot of people. But Newton Isaac influenced and actually revolutionized a lot of our science and math, okay? So Isaac Newton is very clever. Actually, nowadays, you talk about Einstein, you talk about string theory, talk about relativity, Newton Isaac already think about it. Okay? I remember I read Newton Isaac, he talked about, you know, when you have a bowl of water, right? If you rotate the bowl of water, what happens to the water inside? You go to the edge, right? The water will like go to the edge. Newton asked, if you have a bowl of water, you are on the earth is rotating. Will the water go to the edge? Okay, and let you think about it. But anyway, come back here. It's actually very common for engineering, computer science, whatever, to do one thing. I give you a function, whatever it is. I want to know what x gives 0. We call it to find the root of the function. I don't know what is that function. A function is g. It can be any function. It can be g equal to x to power 4 plus log x plus cosine to power whatever. I don't care. I give you a function, and Newton can have a method that can find what is the x that gives 0. How? First, I guess x. I don't care, whatever it is. X is equal to my birthday, whatever. And then I try my luck. I try to see whether gx is equal to or close to 0. Okay? If it is, bingo, I'm done. Okay? Your luck is very good. What if it's not? You just need one very simple Newton step. I replace the x by x minus gx divided by the differential of x. Now, I ask you to have your religious faith to accept this first, okay? I'm not going through this. You go back to your numerical analysis or high school to think what it is, okay? Newton just said that if you do that, you keep iterating, you get the answers. Okay? Let's don't talk about why is it so. Just believe it. And if you believe it, that's the code. What is the code? I assume x is anything. I listen to Newton Isaac. Then I use the Newton step. For step 2, I try to see is the error gx, right? I compute gx If this error is more enough that it's close to 0, then I'm done. If it's not close enough to 0, I do that Newton step. And that's it. This can solve most of, but I think the assumption is your function is differentiable. This solves most of differentiable function. Okay? This is all the code I give you. You can even shorten it. Let's prove it's working. How do you implement square root? If let's say you don't have anything, you don't have the Python library, you don't have, all right? How do you implement square root? What I can do is, hey, wait a minute. If I want to find the square root of A, is the same thing I want to find the solution for x squared minus A. Is it okay? If I can find the x, that x will be square root of A, right? So I model this gx is the function x squared minus x minus A. Then I use Newton method. And this is my own square root function. And you can see that I use my own square root to square root 10. And then I put it in x, and x times x is very close to 10. Okay? And I also do this. How do you compute log A with base 10? Log A base 10 is the same thing if you want to find the solution for this equation. 10 to power x minus A. If you can find that x is equal to 0, then you're done. Again, I trust Newton, put it there, and ta-da. For example, I try to do my own log 100, it gives you 2.0000. So accuracy is up to like 10, more than 10 digits. And I can do what is my own log of 234. I compute this and I do it back to 10 to the power x is equal to 234. Okay, of course, I think you can increase the precision by setting the delta whatsoever to be even smaller. But here, I'm demonstrating that you can use this lambda function to produce other functions like integration or differentiation. Actually, there's 1 year we do integration in our PE. Write a lambda function to do integration, okay? Yeah, and you can almost solve any equation by this lambda function, okay? So that is the first part of our lectures. Any questions? I don't throw out the things. And sadly, it's being included in the midterm, okay? It's included in midterm. Now midterm will have a higher order function. So we'll have some question and for you to practice. Before we end, we talk about, last time we talked about lists and tuples. This is not a heavy subject. I just quickly go through this, okay? Why we use the lists and tuples? Let's revisit functions. You remember functions? We talk about what is the mutability of the list within a function. For example, if square is a function, remember that we actually duplicate square or duplicate 3. So if you want to use the block diagram, it's something like this. Y outside is a 3. You actually pass by value is like you put in the free value instead of y into the function. So inside the function, whatever you change the variable, the outside y won't got changed. We talked about it last time. But if you want to be a list, it's like you actually put in the list handle into the function. And within the function, you are using the handle, but the handle will access the original 3 numbers. So that's why inside the function, if you change one of the numbers, the outside one will got changed also. Okay, so that is what we talked about last time in our list. So you may say there are 2 types of function. Some function we do pass by value. This is actually an important topic that if someone passed you a list, should you change or not change the list? I don't mean this always you should or always you should not. You need to obey the specification. For example, the function that do not modify the input, like if you want to sort a list, you can use this sorter function. The sorter function will not change your input L. It will actually produce a new list for you. It's like copying your list, which is sorted for you. But the other one is you will modify the input or yourself, like this L dot sort. L dot sort is, you can see there's no output. It didn't reproduce another one, but it modify yourself. It's not exactly a good analogy, but I want you to notice that the list can be input in the function and duplicate for output, or it can modify yourself. Which one is better? I would like to do something like a performance analysis, because the next thing is, how do you get the last 20% or 10% of the PE? Because you need to go for performance. How? Let me do a very simple analysis. If I have a list of tuples, how do I add one more number at the end? This is very simple, right? Okay. Let's try tuples. Can you add one item at the end of the tuple? No, you cannot. But if you want to perform such an operation, what do? You cannot do like self-modification. You must reproduce a new list like this. Let's say it's a no meaning function. I just want to say, what if I want to add one more items? I need to take in a tuple, but I add one more item at the end, but this actually produce another list. Sorry, another tuple. And when I need to use it, I need to do something like that. My original tuple is 1, 2, 3, 4, 5. But now I add one more items that I become 1, 2, 3, 4, 5, 9, 9, 9. And you can see that this one, you do not modify the original one. Actually, your function will reproduce a new tuple to override your original one. Of course, this one, when you do integers, it's the same. I cannot modify the integer 4 into 5. What is happening if you give a new value to the integer? The modified integer actually produces a new 5 to replace the original 4. So for a tuple, it's the same. I add one more and I replace the original 1, 2, 3, 4, 5. How about list? Well, very simple thing. I can do the same thing like the tuple, right? You can do both, but let's do the first one first. I can do the same thing like a tuple. I add one more item at the end, and then I return the whole list, and I need to replace the list. For example, this list originally is 1, 2, 3, 4, 5. But now I actually add one more things, and I reproduce the whole list. But you know, list can be more clever. You can do this. This one, do you return a list? Does this return working actually? No. This function will return a null because L dot append will return a null. But what you can just do is like this. List is equal to 1, 2, 3, 4. I pass the list inside the function because I trust that it can be modified inside the list. So within the list, I already modified it. I don't need to say list is equal to modify list. Okay? So 3 different versions. You can see these 2 list versions, they're different. The first version is I need to replace the original list because I reproduce a new list. The second one is I directly modify it. Why is so complicated? Because these are 2 methods. And what I want to do is the following things. Which one is faster? When I do faster, I try to push it to the limit. I try to add many, many times the 999 at the end. So you have these 3 versions, right? Version 2, modify list, and so on. So the code I will run n times. This code here, I think I didn't teach it yet. But basically, you use the package time. What does it mean? When you import time, you say start time is equal to time. Time function will return the number of seconds since 1970 January the 1st. Will return you how many seconds has passed since then. It's a floating point number, okay? And why I can use that to time, because I will time it before I run the program, and I run, and then now I get the time again after running the program, but I minus the starting time, then that will be my duration of my time spent in my loop. And if I do that, what happens? This is what happened. The first version 2 is the append. The time I spent after inserting 10,000 items is only 2 milliseconds. But the next 2 is 0.2 seconds. You said, why is it so serious? Is it serious? What if I want to insert 20,000 items? Do you see the timing difference? Is it even double? It's not even double. It's more than double. If you want to exaggerate that, if I want to input 10 times of the items, you need 1.5 minutes to insert that. But your first method only need a few milliseconds. Why? Why is the difference? And maybe you understand or don't understand, but I want you to know that with a slight modification of the implementation, your code can be run a lot faster and slower. This is the graph of the timing. The blue ones is the next 2 slow version. They will increase quadratically according to the number of items. The other one will increase very slowly. Why? Why the tuple version and the list plus version so slow? Confession time. When I was young, I was very naughty in my primary school. So what happened is I usually being punished by a teacher. And at that time, our punishment is copy words. For example, there was one time I was being naughty and noisy in the class. My teacher asked me to copy. Next time, you need to hand in the Chinese words quiet. You have to copy many times to hand it as a punishment. One time, I submitted my 50 times of copying of the words. My teacher say, what are you doing? I asked you to submit 100 times. What will I do? I have 2 choices. Do I go home and be good, copy another 100 times, or do I add 50 times on my copying? Okay, leave it to you to think about this. What if I make the choice and I go back? My evil teacher say, because it's 1 day late, you need to copy 50 more times. So again, do you copy 150 times from scratch or you add on 50 times? This is like the list. When you do the tuple, after you increase the number of items, you have to copy the whole item to the variable. That means if you do it 100,000 times, the first time you copy six items, and then the next time is 8 items, the 9 items, 10 items. You have to copy many times, and each time you increase by 1 item. How many times altogether? That means altogether is you add 6 to 7 to 8 and whatsoever. Is this many number of times? I don't know how. 5 trillion number of times. You need to copy 5 trillions of number because each time you have to copy the whole thing and you have to increase. But how about append? Append is when you want to be clever. I only copy the extra 50 times. of my punishment. So that means even is 100,000 times, my total number of time I need to copy is 1 plus 1 plus 1 plus 1. That is 10,000. And at the end, the tuple version is you need to copy this 5 trillion number of time. And then this one is only 100K number of time. So which one is faster? And which one, when I want to copy, extend the list 1 million times, whatever, which one is faster? This is what a computer science mind have to focus on. When my N is large, what should I do to make it faster? This is your next level. If you graduate from this 1010E, you want to continue, you need to consider that. Even both of the function can achieve the same functionality. Then which one is faster? Of course, this time is the least append win. Okay, the orange lines give you the timing. Then actually the orange time increase a very single little bit, but then it totally wins the number of the times that you do the quadratic increment. Okay. And just ending the story, back to my school of copying, how we cater to my teachers. Yeah, so we try to do that. We copy, we tie the pens together. So we copy 1 time, it become 5 times. And of course, the other one, I really tried this before. Anyone know what's it? I don't know if you know this nowadays. In the old days, people do not have computer. When they write a receipt, 1 copy give to the customer, one copy they keep it in themselves. They use this called carbon copy. The black sheet of paper is when you write on it, the lower one will have this carbon going to it. That means it's like an instant photocopy machine. And that's why your email have this CC. CC meant for carbon copy. And you have even BCC is the next copy. Okay, so that's why you have CC. Okay, so we did that. Okay, just a conclusion about the list and the tuple version. Tuple version will be good if you want to preserve your items. Let's say I want to pass my data, maybe my data is my audio frequency or audio data. Then I want to pass it to a function with a tuple, so it won't get modified. But of course, if you're manipulating things on list, in general, it's faster, a lot faster. But of course, tuple will be slower. But the other things, you need to depend on what is the usage of your function. Some function is modify your input. Some function you have to keep your input. And lastly, I want you to notice one thing. In our PE, 99% of the time, I do not want you to modify the input, including the coming assignment. Okay? If you modify the input, that means you did something wrong. Then you think about how do you finish our assignment without passing a list into you that you don't modify the input to accomplish the result. Okay? So that's it for today. I guess there's not much question. And remember that we have the exemplified mock midterm, and our midterm is when? After you come back the Saturday, right? Yeah, so good luck.